The fuck? Hello? Hello? Let's see, that should work now. Hello? There's no volume here. Turn video. Your volume. Hello? Hello, hello? Please check your email.
Hello, Brian, teacher?
Yes!
Oh, can you hear us?
Yes!
We can't see you.
Y yes, so, if she checks her email, I gave her a link to, the YouTube that has a, live stream of my computer screen right now. That's a direct link to my computer screen, but she still needs to check her email because I emailed her the documentations that we're going to be covering. Do you have a link up? Um, are you I emailed everything to.
no, Steven, we're working on it, Brian, teacher.
Okay. Hello. Can you hear me?
Hello?
Good?
Mm-hmm.
Okay.
Yeah.
So do you have did you check your emails? Do you have the documentations up?
Yeah, and then she's gonna go print them for me as well.
Uh, okay. Um, Okay. Do you have access to the live stream right now? Are you watching my computer screen?
Yeah.
Okay. All right. So can we start?
Yes.
Okay. All right. So again, if you want to continue tutoring, so this is sort of like the format. Just tell me what you want to cover, and I will email you a day before. The notes that I made for that section, as well as problems that we're going to be working on, that hopefully is going to give you a better understanding. Two, if during any time during the lecture part of the tutoring, if you have any questions, just stop me, right? Because this is a general idea of the whole section, of the whole chapter. So I already know that your teacher have already give a lecture on this. So make sure that you're asking any questions to make sure that you're filling in those gaps. Okay. So today we're going to be covering chapter the on the computer screen. Is this the correct edition that you have, the third edition, or do you have a newer edition of the book?
I don't know what edition it is. I just know it's not good.
It's this one, right? Okay.
Yeah.
All right. So I have the book on me right now, but on the right-hand side of the computer screen, I have the notes that we're gonna go over. All right. So the first part of chapter 11 is just understanding simulations, but in particular the let me just pull it up really quick. Just understanding randomness, all right? So the first two things that you have to understand is the difference between a fixed behavior and a random behavior, all right? So what do you know of random behavior already? What's the definition of random behavior that you understand?
Random. It's not like us. Like it's not voluntary. Voluntary. That makes sense.
Okay, all right. So the best example I could give is that before I'm gonna try to connect this to something that you already know. So a fixed behavior is like a linear equation, right? Y equals to 2x plus 1. Okay. If you ever plug in x, you're always gonna get a back a y value of 3, right? That's just how a function works. So we call that a fixed behavior because there's a fixed input for every single fixed output. A random behavior is that your output is going to be vary based on this idea of chance. All right. The example we use is that a fair coin, when you flip a coin, right, you sometimes get head and sometimes you get tails. The fact that you don't always get one over the other and it is not set in stone, we call that a random behavior. Does that give you better context?
Yeah.
Okay. All right. Can you give me an example of a random behavior and describe how that is random?
Rolling the dice
Okay. And how is that random?
because we don't know which number we land on.
Good, right? The outcome is unpredictable, right? Good?
Yeah.
Okay. All right. So next, we want to talk about. I'm going to be using this example throughout the whole 11 and 12. Is this idea of simulations, right? And so the simulation that we're going to work off is going to be based on this question: how good are you at math? Okay. We're gonna answer that question. Okay. So to answer how good your math is, we're gonna simulate by taking tests. Is that fair?
Yeah.
Okay. Right. So each test is considered a trial. Right? What I mean by trial is that it is just the definition of trial is basically the running of your simulation. Alright? So in the coin scenario, it would be flipping a coin. In your dice scenario, it would be rolling a dice. And in our scenario, in terms of seeing if you're good at math, you're going to be taking a test. Good so far? Okay. Now, this doesn't occur on the AP test. They never actually ask for you to conduct a simulation. in this sort of format, but I assume your teacher is going to ask you how to conduct a simulation. Is that fair?
Yeah. And
Okay.
then she gave us like a table of random digits. Like she gave us a packet of notes and then
Yeah, that I'm gonna explain what that's for, but that's gonna be in the next section where why there is a random packet of digits. Okay, but we're just going to right now talk about the parts for a simulation. Okay, good.
yeah.
Okay, so these are the steps. Okay, the first step is to identify the component that is going to be repeated. A simulation, something always has to be repeated multiple times, right? In our scenario, we're trying to test if you're good at math. So guess what we're going to repeat? You taking tests, correct? So trial always has to be repeatable, okay? Next, you have to explain your outcome, okay? In our scenario, we have two choices. I can give you a letter grade, right? A, B, C, and D, or I could just give you a pass or fail. Okay? It's going to be up to you to decide the outcome of your each trial. Okay? Most of the time, the pass and fail are always the best option. The reason why is because you're going to be studying something called a binomial distribution later on, and that always goes on a pass-fail scenario. Okay? Any questions so far about the first two steps?
No.
Okay. Next, you want to explain how you want to assign the score and your tests. Okay? Because I want to test if you're good at math, so I have to sort of randomize the different types of math questions I give you. Does that make sense?
Yeah.
I can't give you all the math questions in the world, can I?
No.
No. So I have to pick away. Okay? I have to pick away. I'm not going to go into detail about this right now, but when we go to sampling, it's going to make more sense. Okay? But for right now, we have to develop a way to make you take random questions of math. Okay?
Mm-hmm.
Next, this is a key part is to make sure that you state what the response variable is. What I mean by the response variable is to in our scenario is to see how good the student is at math. It's basically the outcome, right? So you want to make sure you clearly state the response variable. So in your coin scenario that you brought up, you can be it can be I'm gonna note if every single time it's an even number, or I'm gonna note every single time it's an odd number, or I'm gonna note wherever it's not one or wherever it's not two. Right? It's any condition you set for the response. Okay?
Okay.
Okay. It's sort of abstract, right? It's sort of abstract right now, but we're gonna put it into a little bit more context in a bit. Okay. Then lastly, you have to run the several trials, right? So for you, I'm gonna be making you take a couple of tests. After you take the couple of tests, I'm gonna collect and summarize the results.
Mm-hmm.
After and scroll down, I think it's in your last page. Um, you should have a table like this. Hold on. The screen takes 5 minutes, 5 seconds, right? Do you see this? The table?
Yeah.
Okay, so that table is the way I am going to organize the response variable.
Okay.
Okay? So on my left is trials, the topics covered are in the middle, and the outcome, right? That's my response variable. Does that make more sense now?
Yeah.
Okay. Okay, so from there, and we're gonna state our conclusion, but we're gonna have to, for right now, it's really hard to state your conclusion until we sort of throw some math, because you're gonna be applying some math, some stats operators in there to state a conclusion. Okay, but this is the format and the structure of a simulation. Any questions on the format of the simulation, or or any parts of the simulation?
Simulation I somewhat understand. I think it's more of like we're asked like it's chapter 12 I think with the sample surveys.
Okay. All right. So, but now we're gonna bring it to chapter 12, where we're gonna sort of connect sort of where the sample part comes in, right? So remember in our simulation, I said that I have to give you a different random math test,
Yeah.
right? So my question is this: how do I pick what questions to give you, right?
Mm-hmm.
Okay. Before we get there, I want to make sure. Are you okay with the idea of population and sample? Because this is actually a very important AP question as well.
Like the definition of
Or
sample.
the idea of the population and sample and where biases occur.
Um, I know bias is like there's like the voluntary response bias, the
Okay, but
non-response
why
bias.
does bias occur in any sampling?
Because I'm not really sure.
Okay, scroll down and let's look at this at the circle diagram.
Okay.
So there's an entire population. So in my scenario that I asked you is I'm gonna see how good you are at math. The whole population would be every single mathematical question in the world, correct? Right?
No.
Okay. This, but I cannot make you take every single question, so I'm gonna sample. So I'm only going to be taking a select
Yeah.
problem. Come on, come on. Okay. And it is in that process that I am only getting a sample that that biases occur because I cannot grab the entire population, right? It's in that process of grabbing a sample that biases will occur. Good?
Yeah.
Okay. All right. So, right here, I mentioned that the entire subject of math is a population, so I have to only ask you for a few. All right. So, okay. Now let's before we go to that, we have to also talk about the sample size, all right? So my question to you is this, right? How many math tests should I make you take to answer that question of how much math, if you're good at math or not? Should I give you 10 tests, 100 tests, or 1,000 tests?
Isn't it 100?
Hmm?
100?
Why do you say 100?
Because like the sample size is like the sample size of n is like 100.
Okay, so you're trying to
Our teacher.
yeah, no, you're trying to answer it very like using math words. I'm just trying to get you to sort of see this from like an average student point of view. What is the difference between taking one chapter test in a whole year versus taking 10 chapter tests in a year? Like, what do you think is going to give you a better measurement of your grade?
A year.
Say that again?
A year? Like
Yeah, but
100 a
but
year?
let's say you took only one test that year, right? And that's going to determine your grade. Do you think that's a good assessment of your ability?
No.
Why?
Because it's only one test that shows
But
like
but what about that one test? Maybe that's a topic that is very hard for you. Maybe that test is the test that you didn't study for. Maybe that test was the one that something else happened. Correct? There's all these other variables that can affect that day's test performance. Correct?
yeah.
Right? But if you take over 100 tests, shouldn't all those bad things and good things average itself out? Right? Maybe your second test you got enough sleep. Maybe your third test you studied really hard for. Maybe the fourth test all the questions were easier. Does that make sense? So, as we take a higher sample size, we limit error because all the variances cancel out. Right? All the pros and cons cancels out. Okay? This will tie into an idea called the law of large numbers. Okay? For you, I think the rule is 30. Okay? So, alright. So now we're going to go to the different types of samplings, okay? So, you know the list of variables that your teacher gave you? Do you know what category that falls under?
Like category as
Types of sampling.
um, like simple random
Correct.
sample.
Correct. That is your simple random sample. Okay? So I'm going to give you a scenario. So let's say it's a list of numbers from 1 through 9, correct?
Yeah.
Right? Okay. So we can just do this. You have to watch the computer screen for this part. Uh, 3, 4 would be, let's say, ratio. 5 can be irrational. 6 can be sequences and series. 7 is going to be inequalities. 8 can be systems of equation. And 9 can be dynamic situations. Alright, so what I did here is I generated sort of a uh, different values for your tests, okay? And I list them out 1 through 9 based on if we are going to follow the simple random, the SRS, right? Based on your number line, this is how I'm going to give you a test, okay? Does that make sense? So what's your first number on your list?
Linear equation.
No, on your list that your teacher gave you, your list of random variables.
Simple random sample.
Yeah. What's the first digit in that random series? In that random.
She didn't really give us digits. She just gave us definitions.
So one common one is right here. Do you see the computer screen? Okay, right. This is something like a string of random digits, right? So if we use this list, here I could make it bigger. If we use this list, the first one is 2, right? 2, 2. Okay, so that means my first test, I'm gonna give you a test on 2D geometry. Okay. Right. The second test, I'm also going to give you a test of 2D geometry. Then the next one, it's 1, so I'm going to give you a test on linear equations. Then it's 7. Then I'm going to give you a test on inequalities. Do you see that? Do you see how I'm using the series of random digits to give you to run my different trials for the simulation?
Yes.
Good?
So, like as the numbers keep going, like using the different tests, right?
Yeah. Good? Okay. All right. So that's how you use a list of random variables. It gives you the conditions in which you run your trials. You look confused. Do you have a question?
No, I'm just. So like if it's number 6,
Uh huh.
then you would say it would be the series and sequence systems.
Correct. Good?
Yeah.
So that is just using the SRS, a simple random sample. Okay? Good? Next, we are going to, what about if we stratify the samplings? Okay? To stratify is when we have to group it by characteristics. And each group is going to be called this word called strata. Okay?
Mhm.
So, now, let's say you have this. Okay? You have 9. I think, or are there more? Okay, there's more. Here, let me just make a little bit more here. 11. Surface area, nonlinear equations could be 11, and let's. Do I already have irrational? Okay. Graphing inequalities. Nope. Transformations. Oh, data analysis. Perfect. All right. So let's say I had these 12. Okay, and I want you to do a stratifying sampling. What would you have to do to this if I asked you to do a strata sampling? Hello? Wait, what? Do we cut off? No. Hello? Ah, I hate when this happens. Ah, is this from my end or her end? Oh no, it's from her end. Hello?
Hi, Brian, teacher of the CL Academy.
Yep.
And yeah, we have an internet problem all of a sudden, and we're trying to fix it. So
Okay.
that's why Amber's disconnected, and we'll try to fix it as soon as possible.